Mother Nature strikes.
Oh my God!
Do you need help?
I'm okay.
Wood saves lives. It's often all that stands between a home and imminent disaster.
See the hurricane coming in, you see the news, and everybody's nailing up the plywood over the windows on the outside.
Why is the scene repeated every hurricane season? Because wood is able to overcome its greatest weakness and morph from a round tree trunk into perfectly flat planks that are incredibly strong.
It really adds a lot of strength and stability, more than just natural wood would have.
Kind of look at a piece of wood, but there's a lot more that's going into it than what you think.
The Achilles heel of raw timber is that it's 40 times more vulnerable to stress along the grain than across it. That's why you split wood with an axe by chopping into the top and not horizontally against the side.
Wood grain runs vertically along the axis of the plant. When you split a piece of wood along that axis, the cells peel off apart.
But by cross-layering thin strips of wood at right angles, the grain weaves together to create perpendicular bonds that give ordinary wood fibers super strength.
Well, plywood was developed to try and get around some of that problem with all of wood's strength being in one direction.
This may seem like modern technology, but it turns out that plywood has been used since the Gerson period of ancient Egypt, 5,500 years ago, and it was made much the same way. Thin strips of wood called veneers were glued together to create plywood, but the process was time-consuming and expensive. Then, in the 19th century, thanks to rotary lathes and improved bonding agents, plywood became one of the most affordable building products available, the first engineered wood known for its great strength and low cost.
3/4 plywood, you gotta pay attention to everything over here. He's got a little bit harder because he's gotta make sure we don't get hit.
Today, the U.S. manufactures 12.2 billion square feet every year. Most of it is for construction. The rest is used to prevent total destruction.
Did you see that? The whole house came apart.
Columbia Forest Products runs its plywood mill in Old Fort, North Carolina, 5 days a week, producing 12,000 plywood panels every day.
I count these boards in my sleep.
The plant specializes in high-grade poplar, made using one of the tallest trees growing in the southern Appalachian Mountains, the yellow poplar.
It grows straight, it grows very fast. It's a lightweight wood.
Because it grows fast, there's an available supply of yellow poplar in the forests of North Carolina. Its straight logs and low-density wood offer two more benefits that make it perfect for transforming into plywood.
It has good workability.
That means poplar logs are well suited for the radical transformation that happens inside the lathe peeler. The straightness of the log allows it to line up evenly with the blade on the lathe. And though poplar is technically a hardwood, its cells are less densely packed than most hardwoods, which allows the wood to peel like an apple. Every day, 3,600 8-foot logs meet the edge of one of these blades. That's 190 each hour.
It's a pretty amazing process.
The blade continuously shaves thin sheets, perfect for layering into plywood.
It's going to lay pretty flat for me, or we've done something wrong.
Giant lathes like this peel 46 feet of log in a single minute. And under such a high-intensity workload, the spinning wood quickly wears down the 4-foot steel blades.
To keep a good, consistent peel, they're changing blades about every hour.
The moisture in the freshly cut poplar logs makes them easier to peel. But there's always the danger of warping. That happens when wood dries unevenly and starts to ripple instead of laying flat. To prevent warping, peeled layers head immediately into the drying kiln.
It's dried down to this level in the kiln, where we basically control the drying and keep the timber straight and use it dry so that it doesn't change in dimension.
Once dried, Every other layer is coated with glue and placed grain across grain in a giant press.
You know, you want to warm your panels up, put the pressure there so you get a good bond to where when our customers get it, it doesn't fly overboard.
The press exerts 175 pounds of pressure per square inch and heats the individual boards to 255 degrees. This combination of force and heat seals the bonds between wood layers. Finally, lasers guide saws cutting 4x8 and 4x4 panels, which head onto the sanders.
You ever heard this whole saying that you can't see the forest for the trees? Well, I've looked at that and I don't see it, but you'll come across some panels that are so beautiful.
Wood grain grants plywood both beauty and brawn, but how strong is it? Facilities like Wood Research and Development in Corvallis, Oregon, test panels and other wood products to find out, one crunch at a time.
You have big machines that push and pull things until they break.
Tests demonstrate that the strength of plywood provides a life-saving barrier when other pieces of a wood home become deadly projectiles. And when used to build sturdy wall sections, it's possible for plywood to stand up against winds from a Category 5 hurricane.
So a 120-mile-an-hour wind on the face of a building can create upwards of 28 pounds per square foot. And this type of lateral load combined with the vertical loads coming down from the building are the types of things that blow over buildings.
Here's where plywood's cross-ply construction really goes to work. This stack of 2x4 boards and plywood simulates what happens when extreme winds hit the side of a single-family home. Even as a hydraulic cylinder bears down on a wall panel, the plywood doesn't break until the force simulates winds blowing 500 miles per hour. That's stronger than any wind ever recorded on the planet, and it's a technology that's an incredible 5,000 years old.